In lecture 2, I wanted to take one problem from cross product based on the difference of sets where the students often get confused. Okay, so I am taking such a problem today, but before that we shall explain the concept, and that is a good chance for those students who could not understand the concept thoroughly in chapter 1. Okay, understand the difference of sets. Set A minus B means that the set of elements that will be present in A but not present in B. Similarly, B minus A is the set of all those elements that belong to B but do not belong to A. Okay, these are the definitions. Take two examples to understand two situations. A is equal to 2, 3, 4, 5 and B is equal to 4, 5. Okay, so here we see that A is the superset of B or B is a subset of A. Okay, so let us see what happens. A minus B. A minus B equal to, by definition, what we can write? To start the set, see the two element and see there 2 is not present, so you write 2. Come to 3 is not present in A but not in B, so one more element 3. Then see 4 is there, cancel, don't take. 5 is there, cancel, because by definition only those elements present in A but not in B are the third set of A minus B. Okay, so this is the result, and we observe that a subset has been subtracted from its superset. Okay, now reverse thing, let us see. B minus A equal to, come by definition, the elements that should be in B but not in A. So I see that here 4 and 5 are the elements, and I come here to see, I see that 2, 3, 4, 5 are existing. So it is not like that exist in B but not in B. It is in B also, so you cannot take it. Okay, so we did not find out anything. This case will be 5. Now let us come to example 2. A is equal to same previous set, 2, 3, 4, 5 and B equal to set of elements 7, 8 and 9. Now see A minus B, C2, go there, no 2 not present in A but not in B, so I can accept it. Then 3 not present there, take 3. Then 4 not present, then 5 also not present. So this is the set. Okay, and ultimately we see that the set A itself. Now come to reverse B, from B to A minus B minus A is equal to 7, first element, come here, no 7 is there present. So by definition the elements should be existing in B but not in A. So I have got one element 7, and then 8 also not there. After that 9 also not present. close. Even though I see that 2, 3 are extra things in that second set existing, this is not our concern by definition. Okay. Now one more thing, look at here. A and B, these two sets are originally disjoint sets. 2, 3, 4, 5, and here 7, 8, 9. Completely different elements, okay, in the two sets. And such two sets are called disjoint when there is no common element found in between two sets. They are known as disjoint sets, okay. So these results we can summarize to remember those things. Okay, so this example, I think that this example has clarified your doubts. Okay, some remark is there, you can take it. I am giving in printed form. Let us take a problem based on the disjoint sets. Question: if set A is equal to 1, 2, 3, B is equal to 4, C is equal to, sorry, the board is shaking. Actually, I am getting the things corrected within a short days. Okay. It is for some system problem at the beginning. Okay. This side, verify that this A cross B minus C equal to A cross B minus A cross C. You have to verify. Okay. Solution: left hand side A cross B minus C equal to, what can I write? You see that A is this and B is equal to 4 and C is the set of 5 only, one element 5. So these two are disjoint, and already we have seen that for two disjoint sets, if A and B are disjoints, then A minus B is equal to A itself and B minus A is equal to B is returned again. Okay. So on that basis, I can write equal to A cross B, because B minus C equal to B. You can write here B and C disjoint. Okay. So equal to, you can write A is equal to 1, 2, 3. 1, 2, 3 and here cross B is equal to 4 and equal to 1, 4, 2, 4, 3, 4. 1, 4, 2, 4 and 3, 4. This is the set. Right hand side A cross B minus A cross C is equal to 1, 4. Same thing what we have written first. 2, 4, 3, 4. And then minus this A 1, 2, 3 and C is instead of 4 it is 5. So 1, 5, 2, 5, 3, 5. 1, 5. Now you see that whatever it is, what that we are set, no, 1, 4, 2, 4, 3, 4. The elements whichever are present in A cross B, because A cross B is a set, so A cross B, those elements must not be present in A cross C, okay, A cross C. So do you find anything? No. 1 comma 4, it is not available. Okay, like that 2 4 3 4 not available here. The completely disjoint sets. So this set itself equal to set this itself 1 comma 4 comma 2 comma 4 comma 3 comma 4. If you want, you can give a hints, since sets are disjoint, therefore left hand side is equal to right hand side. Verified. This is the proof. Now we shall try to understand what is meant by relation. Having understood the concept of cross product of two sets A and B, okay, so we are going to define the relation supposing two sets A and B. Okay, definition of relation: any subset of A cross B is said to be a important note on relation. Number one, the relation from a set A to a set B is denoted by ARB. Means R is the symbol of relation and it is showing that it is from A to B. So A is the prefix and B is the suffix. You have to write in that way, or simply R, or other way R colon A arrow B, means relation is from A to B. Okay, so number two, a relation is governed by a rule always. Number three, if the number of product in A is equal to P and the number of elements in B is equal to Q, then number of elements, A cross product B means the total elements, equal to PQ, and number of subset of A cross B is equal to 2 to the power PQ. You remember that you have got there. Okay, now by definition you see that the definition you have got that a relation is a subset. A relation from set A to B is a subset of A cross product B. Okay, and since subset number of total subsets equal to 2 to the power PQ, it implies that the number of possible relations are also equal to 2 to the power PQ. Number 4, relations are described by either set builder form or through roster form or by an arrow diagram. And when to use which, you will understand when you are going to practice the standard problems. Anyway, I am telling some hints actually. The set builder form is maximum used by the questioner, and roster form also used by the questioner sometimes, and error diagram very rarely, but student can use it frequently, and especially in class 12 relation and function, this is mostly used, and in this class also we shall get some uses properly. And roster is, you know, actually from chapter 1 you have known that it is in a list form. Okay, and set builder form also you have practiced in chapter 1. Okay, still we shall see that how one is converted to the other, and very important things how we are producing the answers. I will illustrate through my examples or standard question. That how this is converted to that one in the form of answer. Okay. Yes. Concept clarification on the set builder format, roster form and arrow diagrams. Very important things. Okay.